All right, today I'm going to talk about notation. Notation is how you represent different numbers, how you represent your answers for different numbers. There are different times that we would want to use different kinds of notation. The primary kind of notation that I'm going to use is called set builder notation. It's the one that you'll see me use the most often, but it's not the one that I'm going to start with because it takes the longest to explain. The easiest to explain is called roster notation. Roster notation, what that means is it lists everything that's on the roster. Like if you think about sports, when you're listing everything that's on the roster, if it's not on there, it's not part of the answer set. That's what we're looking at. So if I have something where I solve for a variable like a quadratic, and let's say I solve this out and I find out that the answer is -5 and -1. There are two answers here. So in roster notation, I would list both of these as my answer. The way that you list it is you put this sign, -5, -1, and this sign. I call these Batmans. I don't know what their technical term is. Put Batman -5, -1. Everything that's a possible answer, everything that's on the roster goes in here. Now the difficulty with roster notation is that you would only want to use that when it's easy to display who's on the roster. If I had all of El Paso on my roster, I wouldn't want to do this because it would take too long to display all of that. Just like if I had all of the numbers from -3 to 3 on a number line, I wouldn't want to use roster notation because it's not just -3, -2, -1, 0, 1, 2, 3. It's -2.975432, blah, 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 blah. So I don't want to use roster notation for this. I just want to use roster notation when it's easy to demonstrate all of the solution set. If I had something like all even numbers from 1 to 10, all even numbers from 1 to 10 would just be 2, 4, 6, 8, 10. All even numbers from 1 to 10, I could put 2, 4, 6, 8, 10. Put my Batmans on there. But another thing that I could do is I could establish the pattern. Let's say I had all even numbers from 1 to 100. All even numbers from 1 to 100 would be 2, 4, 6, 8, 10, all the way up to 100. That's going to take me a long time. So what I can do is I can establish a pattern. 2, 4, 6. That shows the pattern is that it's increasing by 2 every single time. I put ellipses in there to show that the pattern continues. And I put the last value to show that's where the pattern stops. So that's still roster notation. It shows all of the values on the answer choices. Shows all of the, not choices, all of the answers. And it's still roster notation. Okay? Now if I have something like the example that I said on the other side, from -3 to 3, I would want to use what's called interval notation. Interval notation is great when you're dealing with inequalities. Interval notation shows the starting value and the ending value. Starting value to ending value, okay? So with the example that I did, these circles are open, which means that they are not included. On interval notation, you show that it's not included by using parentheses. So parentheses -3 to 3. This is my starting value, this is my ending value. -3 is not included, 3 is not included. If it were included, let's say that the -3 was included, but not the 3. What you would do is you would show a brace. This means included. Brace is included, parentheses is not included. And if they were both included, of course, it would be -3 to 3. Now what happens if it's going on forever? So this is -10 and everything above it. -10 is the starting value. the ending value is infinity. Negative 10 is not included. Infinity is a concept and not a number, and concepts can never be included. Infinity can never be included. What if it's going the other direction? Starting value is negative infinity. Ending value is negative 10. Negative 10 is included. Negative infinity is a concept. It can never be included. It's open. That's interval notation. We would also sometimes represent this with set builder notation. Set builder notation, you're going to say, Batman, your variable follows the rule, and then you give me the rule. So on that first example that I had where it went from -3 to 3, both of them not being included, I would say -3 is less than x is less than 3. And close the Batman. So we say x belongs to the rule, or x belongs to the set such that -3 is less than x is less than 3. Okay? I would also want to probably use this if it was something like this. Because there's a break in the middle. So I would say x follows the rule. We're always going to have this. You can use a different variable, but we're always going to have something like this. We're always going to have the line. That tells me it follows the rule. And then you're going to give me the rule. X follows the rule that 1 is less than, no, 1 is greater than x, or, because it doesn't go in between, the way that I say or is I put this, union. That means or. Three is less than x. Now if I wanted to say and, which I don't know why I would just write it like this, but if I wanted to say and, I would go x follows the rule that 1 is greater than x, and this means and 3 is less than x. Now that's a different problem. It's not the same picture that I drew right here, but that's how you would say and, okay? And you can put anything in there. So if I said all even numbers between 1 and 100, x follows the rule that x, it belongs to the set. This means belongs to the set. I want it to be even numbers from 1 and higher, so I'm going to say that it's that it's natural, belongs to a set of natural numbers, where 2 times x. And I do 2 times x because that gives me even numbers. 2 times 1 is 2. I don't know why I got confused there. 2 times 2 is 4, etc. So that's going to give me even numbers. And x is less than 50. Because I want it only to go up to 100. So if I do 2 times 50, that's going to give me 100. Okay, so I'm going to rewrite that one just because I had to go 2 lines, and I want to make it real clear what I'm doing here. So x belongs to the rule that x belongs to the set of natural numbers where 2x and x is less than or equal to 50. So it's natural, which means I'm starting at 1. So I don't have to re-say that it's greater than 1. This natural tells me it starts at 1. I do 2 times 1, and I keep going until I get equal to 50. And that's what gets me from 2 to 100. Hopefully that makes sense. I'm going to explain it a little bit more when you're in class, and we're going to go over a bunch of problems.